Hello everyone. What we're going to do today is we're going to look at what is called boundary lengths, or otherwise commonly known as perimeter. By definition, perimeter is going to be the length of a closed shape. Now, if we wanted to go ahead and translate that into mathematical terms, we say that the perimeter of a shape is going to be equal to the sum of its sides. So if we take the sum of all the sides of a closed shape, and we add all of those sides up, we come up with what is called the perimeter of that particular shape. And so this is the shorthand mathematical notation that we will use to go ahead and calculate perimeter. And this is always going to be the initial statement for problems dealing with perimeter of a particular shape. So let's go ahead and take a look at an example. Here's a shape that we have. Of course, this is just going to be a right triangle. It has a height of 3 centimeters and the base of 4 centimeters. And then we also have a hypotenuse, and let's just say that we don't know what the length of that hypotenuse is at this point. So if we wanted to find the perimeter of this particular shape, what we're going to do is we're going to use this initial statement, but we're going to be a little bit more particular about what this shape actually is. And in this case, it's a triangle. So notice that instead of writing the perimeter of the shape, what we're going to write is the perimeter of the triangle. And we're going to use a little triangle symbol there to represent that. So the perimeter of the triangle is going to be the sum of the sides. So what we need to do next is we need to just go ahead and add the sides. So we have 3 plus 4 plus x. Now, in order for us to go ahead and calculate the perimeter of this triangle, we need to know what x is. So in order to figure out what x is, we're going to use another initial statement to do that. And since we know that this is a right triangle, we can actually find x by using the Pythagorean theorem. So our initial statement to find x is going to be the Pythagorean theorem, which is a squared plus b squared is equal to c squared. And if I substitute the values, so I got 3 quantity squared plus 4 quantity squared is equal to x quantity squared. I can simplify that to 9 plus 16 is equal to x squared. So x squared is going to be equal to 25, and if I take the square root of both sides, I get x is equal to 5. So therefore, what I know is that x is going to be equal to 5 centimeters. Now that I know what x is, I can then go back to my original question about what the perimeter of the triangle is, substitute the 5 for the value of x, add those two values, and come up with the perimeter of the triangle is 12 centimeters. Okay, and there's what your solution would look like. Now, what happens though if we have curved arcs in our shape? Notice that with the triangle here, all the sides are straight lines, but in this particular shape, notice that we're going to have what are called arc lengths. Now, in order for us to go ahead and calculate these lengths of arc lengths, we're going to have to assume that if we encounter an arc length in the problems that we see, it's going to be part of a circle. So we need to go ahead and find the perimeter of the circle. Well, the perimeter of a circle is not called the perimeter of the circle. In mathematical terms, we call that the circumference of the circle. So we have the perimeter of the circle is really the same thing as the circumference of a circle with a given radius. So if we have the circumference of a circle with a given radius, we can determine what that arc length is by just simply taking 2 pi and multiplying it by the size of the radius. Now, if you don't have the radius but you have the diameter, then you can just simply go ahead and say that the circumference of a circle with a particular diameter is pi d. Okay, so let's go ahead and take a look at this particular example here that we saw. And notice that in this case it looks very similar to a square with this top right hand corner being 1/4 of a circle. So what we're going to do then is notice that we're going to say the initial statement is the perimeter of the shape is equal to the sum of the sides. And in this case, notice, we don't know any particular name for the shape. So what we're just going to do is we're going to leave it as shape. But notice that the initial statement is exactly the same. And all we need to do now is just go ahead and add the sides. So notice that we have one side here, and I'm going to call that S. Another side here, which is that S, plus half of a side there, plus 1/4 the circumference of a circle with a radius of 3. So notice that this expression here is very, very complex in the sense that it involves all of the different things that we need to do in order to calculate the perimeter of the shape. So what I'm going to do then is, since I have one s plus another s, well that's two s's, plus a half of s, well that's going to be 5 half s's, plus 1/4 the circumference of a circle with radius 3. So if I go ahead now, I know that s is going to be equal to 6, so 5 halves times by 6, plus 1/4, and now we're going to go ahead and determine the circumference of a circle with radius equal to 3. We can do that by saying 2 pi times it by 3. And then if we go ahead and simplify that, we're going to come up with 3 plus 3 halves pi centimeters, which is the exact answer, which is also approximately equal to 7.71 centimeters. Okay, so let's kind of wrap up some things here. Let's wrap up some things here. Remember that the boundary length of the perimeter is the length of the closed shape. This is the initial statement that will always apply to perimeter. If we can, we want to go ahead and name the shape more specifically, but if we can't, we can just leave it as the perimeter of the shape. If there are arcs in the shape, then of course we need to go ahead and assume at this particular moment in time that the arc is a part of a circle, and then we can incorporate the initial statement or the circumference of the circle into our expression for the sum of the sides. Now, in terms of solving these problems, there's some things that you really want to be very careful about. Again, remember that we want to start off with your initial statement, because our initial statement is going to drive the solution process. Work down, so notice working down, even in this case I'm working down, and line up your equal signs. So notice that all of my equal signs are lined up here so that I can keep the left and the right hand side of the equal sign very, very clear. So even here, lining them up. Okay? Answer should be a complete sentence with units of measure. So notice that if I read this as the answer, I'm answering the question that the question is stating. Perimeter of the triangle is 12 centimeters. The perimeter of the shape is 3 plus 3 halves pi centimeters, or I could say the perimeter of the shape is approximately 7.71 centimeters. Okay? And the last thing, the exact solution is preferred. So if you can get something that looks like this, that is preferable to this, and then within certain contexts it might be more appropriate to go ahead and answer with this further. So let's go ahead and take a look and see whether or not we can solve the problems that we'll look at the next time that we take a look at this particular section. So see you in class the next time. Bye-bye.